Hi everyone, welcome back to Linux. Today we are going to see about linear regression. The linear regression is a supervised machine learning algorithm that the model will find the relationship between dependent variable and one or more independent variable by fitting within a linear equations. Let's first see linear equation. We can have any number of x and m, and this equation is called as linear equation. To understand more about this equation, let's take smaller example by taking only one variable, that is y equal to mx plus b. Okay, and to you have been study this in school, and for simplicity we take m equal to 2 and b equal to 10. Let's try to understand this equation. Let's put some value for an x. Let's take x equal to 10 and y will become 2 into 10 plus 10 equal to 30, right? Let's try another value like x equal to 5 and y will become 2 into 5 plus 10 equal to 20. Can you see some relationship here? That is, when you increase the value of an x, the y's values also increases. Similarly, when you decrease the value of x, the y value also decrease. This types of relationship is called as linear relationship. Okay, and whenever you find the data set which has like this types of relationship, we can use linear regression here there. And this is how the this is the basic concept of linear regression and how the model will find the relationship. And in general we have an input x and output y, and we give it to in a model. And in most of the real world case, we don't know the value of this m and b. We will give it to in a model, and model will find the best value for the m and b for the given data set. For here we take, for understanding purpose, we simply take this value, but in real world case we don't know. So we'll give to in a model that will find this m and b. Let's see the code in Colab.
Before we build the linear model or linear regression model, we need a data set to train the model, right? So for simplicity, we manually create the data set. For example, let's create a function that will return the some data. And for a linear regression, the formula is y equal to mx plus c, right? We will try to do this. Since because we are manually creating a data, we need to set the value m equal to 2. We can choose whatever value we want and c equal to 10. And this function will return some data set, right? We need to set in a size, how much data it should have to return. Default is 100. That's it. And we need a x value. And we use numpy because numpy do the numerical operation as fast as possible. Or arrange 0 comma size, that's it. And y equal to m into x, right? And m into x plus c. And this data y equal to mx plus c having a perfect linear relationship, right? But in real world data set, we have some, you know, some noises. For this, we actually add some values, some noises. Like, I think this is in a function, and we set as noise level as 0.5, and length will be len of size x will works, or else we can just pause size. I think it's enough. Comma y. I don't know it will work. Let's check. X comma y equal to L per. It works. Let's take shape. Let's see shape, and it's 100 and 100. Okay. Yeah. Now we got an data set. That's before building the model. We need to understand the data, right? Whether this data it's contain the linear representation of x and linear relationship between x and y, right? For this, we try to see in the graph. It will, if you see in the visualization, it will be more understandable. For this, we use matplotlib. Let's plot this. Plt dot scatter x comma y. Yeah, this is our data set. Maybe we can take, yeah, it's fine. This is our data set. Here we can see that when the x increases, the y value also increases, right? That's why the graph like this slope. So this data set contains some linear relationship. So we can use the linear model. Let's build the model. There is a in we will use the sklearn library or scikit-learn. In that sklearn, there is a module called linear model. In that, we have a linear regression. Yeah, here it is. First, we need to import it, and let's create a model. It's actually pretty simple than theory. And that's it. We build the model. And what's next? Let's train our model. And that's it. If you run this, it will train. But there is a catch. We need the x as to be in a two-dimensional array. But here it is in one dimension. But we need to pass into model as in a two-dimensional. If you run this, it will give an error because expected 2D array. We need to change this array into 2D by using there is a function called np.reshape minus 1 comma 1. I think it will works. Yeah, here it shows like model is created, and that's it. We declare the model and train the model. What's next? That is prediction. Let's take model.predict. For example, let's pass 10. It's predicted as 31. Why we need to put two square bracket means because we pass it as in a two-dimensional array, and every time we need to predict some value, and we need to pass the data same as how we passed in training. And for the input 10, it will predict as 31, right? And as I told, we don't need to give these values 2 and c equal to 10. The model will find it automatically, right? It will find a best value, right? But let's see that values. That is model dot something coefficients and model dot intercept. Yeah, this is the values. We take it as m is equal to 2, and this c is called as intercept and as 10. But our models predicted m equal to 1.99 something. It's pretty close, and c equal to 11. Due to the some noises in our data set, so the values also mismatches. And let's do some work. The equation is y equal to mx plus c, right? This is the equation. And now we got the values from our model. That is m equal to, sorry, m equal to model dot coefficient, yeah, of 0, and sorry, c equal to model dot intercept. Okay, and y equal to m star. The input is 10, right? What we are predicting is 10, 10 plus c, and we don't need to put the y equal to and y. And if I'm right, this both value, this value and this value will be same. Let's check that. Yeah, it's same, right? This is how the linear regression will works. It will find best value for the model, best parameter for our model to describe the data. This is how the linear regression works, and that's it. And how, let's think about how the model will predict these values, these coefficients, that is m we called as this coefficient and intercept, how the model will predict this exactly. And before closing up, let's do some visualization. Let's take prediction equal to model dot predict x, x dot reshape minus 1 comma 1, okay. Plt dot scatter x comma y, and plt dot plot, I think x comma y c equal to r will works. Oh, x and y must be in a same length, same size. Let's take x dot shape, y dot shape. Oh, I changed y here, so I need to rerun this. Yeah, I need this, and yeah, now it will works fine. I done some mistake here. This plot should be prediction, right? Yeah. Oh, prediction. Sorry, this should be, yeah, that's correct. This is our data, right? These dots are our data, and our prediction is this line. Do you see that this line is a perfect fit for this data? Not exactly perfect, but it's somehow fit approximately, right? This is how the linear regression will work. It will find the best fitting line for our data. So if you are, if you come upon some value around 120 something, and it will find some values by straightly seeing upwards, and this line will come and intersect with here, somehow some over here, and the expected output value should be some over here. This is how the prediction in linear regression will works. And I haven't told about how this model will find the best parameters during training, right? I will tell that in next video. Thank you. Let's see you on next video.